Hey, welcome to question 5. Again, do please pause the video and have a go at it yourself before pausing to hear the explanation. Part A. We're going to assume that the only possible outcomes on this peculiar roulette wheel are 0, 10, 15 and 20. We have some probabilities here, so we're going to use the fact that these probabilities have to add up to 1, because they've got to include all possible outcomes. So the equation we can use to find k is, I guess, that 0.4 plus 0.2 plus k plus 0.1 had better equal 1, and that gives us k is 0.3. Okay. Now, part B is introducing a new piece of notation, I'll underline that in blue, e of x. That's a sort of capital E, usually with 2 bars, of x. That's the expected score. That's exactly the same as in the previous question. What would we expect the average to be if you did a large number of spins? Now, I'm going to pause. I'm just going to take a second to talk about this x and this same x here. Capital X here represents the score on the wheel after a spin. It's called a random variable, and capital X will take on different values for different spins of the wheel. So if you spin the wheel and it comes out as a 10, then for that experiment x was 10, and if you spin it again and you get a 20, then x is 20. And then we can look carefully at how this table is laid out as well. You've got a little x, which is used to represent the possible values of the random variable capital X, and then here the probability that x is equal to each of those is 0.4, 0.2, 0.3 and 0.1 respectively. Okay, how are we going to do it? Well, the long way round is to say, let's imagine we had n rolls where n was very large, then our average we would expect to be approximately 0 times 0.4n, that's the number of zeros we'd expect, 10 times 0.2n plus 15 times 0.3, that's k, n plus 20 times 0.1n, all divided by n. And hopefully we can see the n's are going to cancel throughout. The n is like a common factor and it cancels out. So what you actually get, and we will use this directly next time, is you multiply each value by its corresponding probability and then don't divide by anything. So it's very similar but slightly different to finding the mean of a list of numbers, 10 times 0.2, in that you multiply the numbers by the probabilities rather than by the frequencies, and then you don't need to divide by the total frequency, because the total probability now is 1. 0.3 plus 20 plus 1. And so we get here 0 plus 2 plus 4.5 plus 2, which is 8.5. So the average score on this roulette wheel is 8.5. Okay. Notice that the average score is not one of the scores available on the wheel. I should have maybe drawn your attention to that last time. That is not a problem. That is the correct expected value. Okay. So now we'll do the variance exactly the same way. Slogan, mean of the squares minus the square of the mean. I will do it with the ends, but you'll see the ends cancelling. So we would expect there to be 0.4n zeros if you spin the wheel n times. So the mean of the squares would be 0 squared times 0.4n plus 10 squared times 0.2n. That's the number of 10s we'd expect. We'd then expect 0.3n lots of 15, so 0.3n 15 squared plus 20 squared times the number of 20s we'd expect to be 0.1n. Divide all that by n and subtract the mean squared. I should write that's the variance of capital X. The n's will cancel. Var of x equals 0 plus 100 times 0.2 plus 225 times 0.3 plus 400 times 0.1 minus 8.5 squared is, I believe, 72.25 as a decimal. Okay, so that's equal to 20 plus 67.5, forgive me. 67.5 plus 40 minus 72.25, which is 127.5 minus 72.25, which is 55.25, I think. Give me a second to check that. 127. Yeah, I think it's okay. So that would be the variance, 55.25. Was the question asking for the variance or the standard deviation? No, the variance. Okay. The standard deviation here would be between 7 and 8. 7 squared, so square root of 55.25. So 7.5-ish away from the average. So if you look at the average is about 8.5 and you think about going 7.5 either side of that, you're looking at scores between 1 and 16 or something. So you're looking at the zeros and the 20s. Yeah, that's half of them. Okay, so that's a kind of plausible answer for the variance. A variance of 300 would have been too much, and a variance of about 3 would have been too little. Okay, so your final answers for the expected value written as e of x is 8.5, and the variance written var of x is 55.25.